Are you familiar with the term resurrectionist?
No, I assume it's someone who resurrects as a profession.
In a way, yes. I thought it'd be fun to learn about concurrency and some of the features of the Go programming language by building our own gang of resurrectionists to go grab some
All right.
bodies. What do you think?
I like it.
Let's start. I'm going to use the touch command, and I'm going to make our first main.go file. Packages in Go, we'll get into packages here, but the first package we're going to use is the main package. And when you tell Go that you have a main package, it means that you have a package that intends to run, right? So if you don't have a main package, that basically means you're creating a library. Otherwise, if you do have a main package, that means you intend this to have an entry point, right? I think that's what we often call how you start a program, right? The entry point. So it's actually going to run something, have output maybe, input maybe, who knows, but it'll have an entry point. So we need a main.go, and we're going to use a function called main also that we're going to see, and it's all going to sit in the package called main. Packages are important in Go. I told you we're going to have to declare a package here in Go, right? And this is our package main. And packages are how you organize code in Go. Packages also kind of act as a namespace. So a namespace acts as kind of this organizational boundary. How would you describe it, Richard?
Yeah, I'd be more philosophical of like everything is a tool for organizing the code, right? From like
That's
your
true.
package to your function to just regular brackets. Like all of these things act as mechanisms.
And they all change the scope, typically.
Yes.
So package is one of the highest levels of scope you can get to. We're going to make a function. It's going to be called main. And this is what's going to run every time that we start our program. Another function that is special that we could have. Oh, go ahead.
Is this like in other languages where it's like the main, like main has a special name that like your main function has to be named main, or is it like in Python where it can be named anything and there you have some other mechanism for pointing to it?
Nope. They just said if you want something to be run, you better have a function called main. So init, I wrote another function up here called init, and you can have init in any package. It sits at the package level, and it runs before anything else. So you might want to call it a constructor, but it's not really a constructor because it's at the package level, not at an object level. Yeah, it's an initializer for the package. So it'll run when the package is imported for the first time. You could actually have a package that has an init function in it, and you can import that package and do nothing with it other than import it, and it'll run that init function.
Interesting. This is in Python they have this, right? You'll see frequently they'll have like if name equals main. That is like the idiom that's in a lot of the Python
underscore
functions.
like double underscore.
Yeah, and then everything is in like the in like a main method because like when you import a Python, if right. underbar name, like the string underbar name equals main, then run like the main function. That's because everything that's not in a function when you import that file will like run. So like if you want to think,
this is Python, not Go.
Yep. And then it'll run. Yeah, because like let's say you had like above this you had like print something, declaring some variables, some other stuff. All that runs when you import it, and you don't always want that. So yeah, that's it seems like Go is taking that and said, well, if you still want that behavior of like run some code when it's imported, like you can use the init, but we're not gonna. Well, I guess I'll ask: does Go support having like? Could you have a print statement right here on line 5 if you wanted to?
Outside of the main?
Yes, like outside of anything, a top level. Can you have?
You can have variables. I don't know if you can have an actual function. I don't know. Let's see. So to do a print statement, you use a package called format, FMT. It's giving me an error, but that's probably because I haven't imported it. Oh, but no, look at the error. Expected declaration. So you can, like I said, you can declare a variable.
which
So I could
makes sense,
say
right?
Richard, right, is of type string here. Let's say I did this instead. Richard, and then so you can initialize a variable and declare it in the same line using this special syntax here, the colon and then equal sign. But this is kind of interesting. This is a choice of the language. So as you saw before, when I just declared the variable, right, without an initializer, it just gave me a warning. But declaring the variable with a value and never using it is an error in Go. Yeah, so if I go build this time, it won't compile. It won't do it. That's an error, right? So that's a very bold choice, you might say. I can do it outside of the main, though, which is interesting.
Why can't you declare it inside the... What does the error gives you when you do it inside?
Unused. It's the unused. Declared but not used.
I'm just guessing here. My assumption would be that if it's outside of a function, there's a possibility that it's imported by something else and it just doesn't have the visibility to see that.
Yeah. Yeah,
like
it could be used. Yeah.
Yeah, some other function in a different part of this package could be using that, and it doesn't have visibility to that. But if you have it inside a function, it is able to make stronger guarantees around what could potentially happen, and it knows that it's probably not a thing you want.
As is tradition, you're supposed to start with a hello world, yeah?
Yes.
I've got a special hello world for us. I'm going to start us out by stating our intention, putting it out into the universe, what we want to do. And so I use this package called format. As you can see, it's part of the standard library. It's just how Go handles input output, basically. So this will output to standard output by default. When you do print line, that's what's going to happen. So I said, I'll show you two different ways that Go works in terms of building the binary, right? So I can do this. I can say go build, and I put a dot to mean the current directory that I'm sitting in, and it can detect that there's a main.go there. It builds it, and I get something called medicine there. If I compile it with go build, right, it's going to take on the name of the package, or the module, rather. It's going to take on the name of the module. I could change that name with this -o. So we'll call it Richard. And there you go. So now I have like two binaries. I've got one that was named after the module and one, and that's basically just what you use to execute your program. It's too many steps, right? I don't want to do that every time I get a build or I want to test something. So the Go tool includes Go run. So this will actually do the build step for you, put it into a temporary directory on your file system, and then automatically run it for you. So if I just say Go run. So you're new to Go. How do you feel so far?
Good.
Pretty straightforward, right?
Yeah, this is you can see some like hints of C++ in this. I can see some the influences from Java. Some of the stuff I've seen with like Rust, I wouldn't assume that it was influenced by Rust, but I could see them like having a common ancestor in that regard in the way it approaches some of these.
You get notes of
notes. Just there's a wafty aroma of Python in here.
So as I was talking there, I created a directory, and then I created a file within that directory with the same name as the directory. I didn't have to create a file with the same name as the directory. I'm doing that just because I want to. I do have to have the directory, though, if I want to create a new package. So if it gave me autocomplete there for me, so I didn't have to remember how to spell Resurrectionist. But let's say under Resurrectionist, people always do this, right? There we go. People always do this, and it drives me crazy. I'm guilty of doing this, where they just name something so vague. Yeah, utilities, and then they just shove everything in there. And they're like, yeah, that goes in utilities. But it doesn't matter what I name the Go files under here. It's still the same package. So like all of the things under this directory will be able to see all of the things inside this package. So like, I'll declare a variable here. And so now I actually can see utility here.
That didn't give you a warning like it did on main.
I'll even set it. So I'm gonna do here. I'm gonna make a function. It's not gonna do anything except for. I'm actually not even gonna do the format. I'm just gonna return I'm gonna have to tell in this function the return type, which is gonna be a string. Yep. I'm gonna return that utility. So you notice it's in a different file.
I hate this so much.
But it's in the same package.
Well, so if you go to Resurrectionist and you do like command click on utility, does it?
I can still go to the definition.
I still hate it.
Now
this is like the everything I hate about Java, right? Where Java, like, you import the entire package and then it's like you just have to know that, like, oh yeah, this one thing was like a first child of that thing. So you have all these things of like, right, where they do like they'll import whatever .star, right? And now they have all those, and then they just say like, oh, I'm going to use, so here it's very clear print line comes from the format library, right? Java, the thing that I hate is like if it had the ability for you to say like import format.star, and then later on you could just write print line, right? Because it's like, oh, well, what am I getting from format and what am I getting from Medicine Resurrectionist? Like, it's not clear by looking at the code where the print line function came from. So if you had in Resurrectionist, you had a function called print line.
I can change the name of the imported package if I want to and rename it. Yeah. I don't want to type out Resurrectionist every single time.
I do hate that you can arbitrarily just say something without it, like importing it into the package. Like, I know it's already in the package because they have the same package name, but like I treat like files. Okay, sure. I'm sure there's a reason for this that I'm not seeing that makes this very clever and useful, but I don't like it.
I wanted to show you. So first off, we could just print this, or we can run this, and I can show you that it works. Right? There's Richard special functions. Right? We got that name. Not from the main package. We imported it from here. It's actually sitting in this utilities file. And then the actual function is in the Resurrectionist file, which can be confusing. You're right to call this out. But the other thing too, if I go, this is a very interesting thing about Go when you first learned Go. Did you notice I used a capital letter here? I don't know if you noticed that or not.
I noticed capital letter, but I didn't think anything of it.
Okay, well now you should, because watch what I can do. I can actually get to that utility variable now. But watch this.
Declare the package level.
Nope.
Oh, I hate it so much. Oh, I hate it so much.
Now it's gone. So a lot of languages have private and public settings on properties or methods when they're declaring classes.
And people would use as a notation, they would use capital and lowercase letters to like help them debug these things to see if they had the scoping wrong. And they have now codified what used to be like an idiom into like a spec for the language.
This is probably not valid Java. I don't know if I can write valid Java from memory, but if you want to make something on a class private and inaccessible to anything that doesn't, well, this is even where it gets more complicated in object-oriented and class-based languages. There's also a setting called protected, right? Private is only accessible to the class where it's declared. If you have something called protected, it's accessible to the class and anything that inherits from that class. And then you have public, which means anybody can get it.
Fun fact, it's all fake.
It is. It's all fake and flimsy, and it's not real security. Don't make it think that like people can't still introspect your code and get to.
Well, yeah, I mean, you use something like JNI and like call out to like a C library that like doesn't give a shit about public or private and just reads variables. And be like, oh yeah, here's a variable some moron marked private. Like have at it.
Yeah, these are as Richard so eloquently put it, these are actually just guidelines or organizational features of a language that is supposed to indicate to another programmer who's looking at your code what not to change or what they can change without messing up internals of a class. So there is no private, protected, or public in Go because there are no classes in Go in that sense. So in order to export something from a package, it could be a variable name, it could be a function name, but to export a value to be used in another package, it has to start with a capital letter.
I hate it so much.
So now I can't actually access that utility string anymore because I've made it. And look, well, I still can access it here because this is the same package. You see, I'm actually going to change this to.
But this so this would work what you have here because then like it is a private thing that then returns is a public thing, right? So if you go back to Resurrectionists, print utilities is capital, so it's available. Right. So like that should work.
Yep.
Right. Yeah. Okay.
I can no longer do
that
utility. Yeah. It's not there anymore. But I still have access to that method because I made it exported from the package. And now I changed it to Richard's digging tool. Are you thoroughly incensed yet?
It's one of those things. It's like, I'm sure there's a reason. I don't like it.
Well, we're getting rid of utilities. We don't need it.
Good.
It's gone. And we're going to organize everything in here instead. We'll get rid of that too. And that's going to have a little red squiggly that we got to get rid of here. All right. Oh, did you notice this? So I got rid of all the references.
Heard about this where it's you now have unused imports.
That's right.
Yeah, and it's gonna throw an error, which I like that because like the number of times I've been like hacking on something in Python and import some stuff, import a package, decide I don't need it, or I refactor it, I don't need it, and I forget. Oh, I had to bring in even things from like the standard library of like time or math or some of these other items. And I realize, I'm actually gonna bring in a different dependency and forget to remove those dependencies, those import statements. I do like that it forces you to remove them.
Now, remember, I showed you this init function, right? I don't have anything exported from this package. Like even if I declare this import statement here, right? And I'll get rid of the renaming because but it still throws an error. But I don't have anything to export and import into here. But what if I need this? What if I need this init to run? Like, what if I have procedural things that I need to happen in here? You can actually, this is called the blank identifier. It's just an underscore. But remember I told you can rename the package when you import it.
If you do underbars, oh God.
If I just do an underscore, now we'll see it. There you go. And so that actually runs before main, remember? I told you anything in init will run. I wonder what the order is, though. Let's see.
I assume that the imports are going to be done first. Your init statement might have things that depend on your imports. So you have to import all of your things before you start calling your own functions.
And you were right. Let's talk about classes. Go doesn't have classes. But we do have structs, right?
Yes, so we have containers that hold data and methods.
That's right. We need to make our first type. We could use some of the built-in types to do this, but oftentimes you want to manage your own state in a type. You want to manage the variable names. You want to manage what are called methods. But a method exists on some kind of object. It's a function that is tied to an object, right? So you can access the internal managed state of an object that within these methods because they're functions that are tied to the object. We need to make our own though, because we've got resurrectionists to create, don't we? We need people out there getting bodies for us. I'm going to make a type. It's declared as struct. And then I open a curly brace. And this is where I declare out my properties. So I actually don't declare out, they call them in Golang fields. So these are fields and they store data types. You can have another like custom type or a user defined type as a field in a type also, in a struct. But we'll keep it simple. Probably need an ID, right, to identify each resurrectionist, because you want to be able to pay the right one,
It's bold of you to assume we're going to pay them.
Well, that's true.
Yeah.
I told you, oftentimes these people acted as, and I actually might want to use lowercase. We'll see.
Yeah, because
I probably
we
don't want to.
We don't want to make their social security number to be just publicly available.
I told you these people act as part of a group often too, like some sort of gang, or a social club, I guess you could call it.
Can a resurrectionist belong to more than one group?
Probably not, because these groups are competing. You could leave a group. You probably can't belong to more than one at a time. But what we could do?
Well, I would assume that a group ID would be a group. It would be a type that contains like an array of members. So like the arrow would go the opposite direction. So instead of it depends. It depends on the what the
data schema.
Our data model is of like, are we going to like give me all the members of one group? It reminds me of the comment by Stringer Bell where he's like, "Are you taking notes on a criminal conspiracy?"
Hey, we could make our own group type here. That's fine. You made a good point. You think these people?
I think for this, I would like inside group. I would have like members as an array of resurrectionists, and then I would assume that a resurrectionist would have like an array of like skills, right? Like I can dig in clay and soil, but not sod or sand.
Okay.
Right. So it's like these are the like Pokemon. This is like the type that I have.
Let's just make that
let's make that string
for now.
I would assume that resurrectionist needs like I think there's like 2 bags that they're gonna want to have of like how much the balance that they're owed. Maybe they drop off a body, they get paid right away, but I assume that it's like they're gonna drop off bodies every night for a month and then get a paycheck at the end of the week or when the body is sold. Maybe they're selling them on consignment. And the other one is like they might have a cart where they can carry more than one body at a time and has body, right? Like does this particular like are they on their way to or from?
Then you only carry one at a time.
If we limit it to like they can only carry one at a time, they're either carrying one or not carrying one. Because if you want to task a resurrectionist, you don't want to task someone who already has a body to go get a body.
Right. Let's come back to that. These are all wonderful points, and we're going to make the.
I'll put it on the backlog.
This is one of the most accurate simulations of grave robbing that's ever existed in computing history, I believe.
Yeah. Oh no, agreed.
But let's move on for now. You may be asking, where's the constructor? First off, what is a constructor?
I mean, a constructor.
What am I talking about?
Typically, it would kind of block off a chunk of memory for an instance of a resurrectionist and say, okay, this chunk of memory is for this one specific resurrectionist. What do they call it? A concrete object. Typically, you call like a new statement, and that like does all this allocation. I think you did it for an int up there before. You said new, and then in the brackets you said int. Right? I would assume that you do that for a resurrectionist.
You don't. Go doesn't have constructors. So if you want a constructor-like experience, you have to build a function that returns an instantiated object. So typically what people do is they create something like this. They have a function called new resurrectionist or new whatever object. They may have like parameters that they put inside here that help with the instantiation. So maybe they have a separate system for creating resurrectionist IDs, right? And then you want to pass in the ID. Maybe the ID will be created in this function body. Who knows? So now you can see, like, I can set the ID to whatever I want. 1, 2, 3. And I don't actually need this line anymore. I'm going to return this, but I have to change my type to resurrectionist. And this is where you dereference with the ampersand. You might want to return a pointer. You may not want to copy it. It's up to you. All right, so I'm setting the ID. I'll set the group ID 321. This isn't going to work.
Why wouldn't that work for the group ID?
It's not going to work because every time we create a new resurrectionist, they're going to have the exact same IDs. I've hard coded the IDs, right?
Yeah. Okay. I think meant like not going to work from a compilation standpoint. Well, they're clones. We don't yet understand how the human body works, but we do have clones.
We have cloning, yeah. So that's an empty slice. So I'm returning that. But what if I want to do something with ID? Can't actually access ID.
Well, yeah, because we made it private because we don't want someone changing their ID.
if I say,
I think this is what I was about to ask about. Of like, those all appear to be optional fields in the struct. Is there a way to make is they default to optional, or is there a way to make required fields? Or this is like an issue I had with like Rust. With like, I wanted a field that was required. Well, if they didn't provide a value, I would insert a value, right? So Python has this of like in the variable in the function definition, you can like put in a default value, and then if you just assign it in the constructor, or like it just below that. But like Rust is like, no, you have to like check if it's none, and then do all or
yeah, no, I don't think it has a language support for this. I think basically if you don't, like if we were in here, right, and we didn't actually set any of this, it's going to initialize all those values to their 0 values. So empty slice and empty strings. I'll just make these public real quick. And then if I print out ID, it's just going to be an empty string. See, nothing.
Yeah.
It automatically does that. So I actually don't even need to declare the skills thing. And maybe I want to leave skills as public now that I think about it. So we can actually just see what their skills are. There you go. See, empty array. And I didn't set that. Well, last thing we'll do, let's say I need to change their ID for some reason, right? Especially group ID. Group ID will likely change, right? We could call it like something like set group ID. Okay.
Yeah, I got some vibes of this of like some of the other language features of like them really wanting people to use getters and setters instead of directly accessing fields or variables or functions.
Well, I mean, we could make it that way if we just make that a capital G.
But that is if you make a capital G, they can both set it and get it. But like
yes.
you might want to think of like, I want someone to be able to read like the group that you're allowed to be, the group that you're in is public knowledge. Everyone's allowed to know it, but only the registrar of groups is allowed to change your group ID. So like you wouldn't want to make it, the capital G would be like too heavy of a hammer for that. Like you'd need a getter and a setter with, yeah.
Make it explicit what you're doing.
In your set group ID, you could implement logic to like check if it's, maybe you can only go up in group IDs, you can't go down, or vice versa, that you can do this logic that you wouldn't be able to do if you would directly expose the underlying group ID.
You notice here, I've got a function, right? But I don't have access to the resurrectionist object. If you want
why does the function not have access to it?
Well, there is no resurrectionist object here, right? Like I can create a new resurrectionist object.
Oh, okay. Sorry, I was thinking of the type. Yes, correct.
But like,
it doesn't have it.
Like an instantiated version of a resurrectionist. There, we can create methods, but we do that a very special way by setting right here. We're going to tell it that we want this function to only operate on resurrectionists. That's it. And this is where it becomes important to use pointers specifically when you're working with methods. Let's do this way first. I'm gonna also make a get group ID, right? So we can actually print out the group ID. All I gotta do is return r dot group ID. I have to tell it returns a type of string. But here we don't want to return anything. We are just gonna set group ID to be equal to some new value. I'm just gonna set it hard coded 456. It's actually giving us a warning. Ineffective assignment. Why do you think that is?
I mean, I assume that you said it was passed by value, so
we're not actually updating the underlying
we're changing object. We were passed a value and we changed that value, but like
we changed original it thing on this copy inside the function, right? This copy inside the function got changed. Actual copy you want to be changed is not being changed. So guess what you got to do?
Pointers.
That'll fix it. There you go. Look at that. So now it says it's okay. We're all good. So now
because it's passing a pointer to an object to be changed, and then under the hood it's doing some magic to say, okay, well, I know how the memory is laid out for a resurrectionist, an instantiation of a resurrectionist, and I know where group ID, like what its offset would be, so we're not doing pointer arithmetic, and then it's making that change without you having to do all of the shenanigans related with like group ID or pointer arithmetic.
So now we can see, and there you go. Our group ID is updated to 456. So that's the basics of structs, and we're gonna keep building out our objects here that we need, because we still need a cemetery. We probably need some plots, but like I said, we're gonna have to build out some more structs here to describe our cemeteries, our plots. And then we're going to go create an army of resurrectionists and let them loose. And we're going to do that with Go routines that we mentioned up front, right? For concurrent programming.
Sounds good. See you tomorrow, same time.
Same time. This is the longest stand-up I've ever had.
Yeah. And this is why we use tabs.
All right, fine. I'll use tabs.